Celestial Navigation, the Sextant. To ensure you don't miss a video, you can subscribe and hit the bell to follow the upcoming videos. I'm hoping to get through all the videos on celestial navigation in the next couple of weeks. I'm not a big fan of math, so I've been procrastinating about doing this part of the course for some time now. Please feel free to comment in the commit section below if you have any extra knowledge or experience to share with everyone. Or if you still have any questions, and then I can go back and do some more research. Your contribution will be really helpful. So let's get started. The Sextant. How do I choose a sextant? I've got a plastic sextant which was given to me. It is a Davis Mark 25 Deluxe Sextant Navigation Tool. You can buy them on Amazon for about USD 160 or so. Plastic sextants are reasonably priced, lightweight and great for beginners or as an emergency backup navigation tool. Being lightweight means they can be easier to hold for longer periods. However, being plastic, they are sensitive to heat and can produce errors if left out in the hot sun due to the frame expanding. Metal sextants are beautiful instruments. They can be considerably more expensive, but produce a more reliable reading as they aren't so prone to temperature changes. They usually have better mirrors and optics as well. Being heavier, they can be more difficult to hold for long periods, but can be more stable in windy or rough conditions. Rona, one of my blog readers, suggests if you can get a heavier sextant like a Plath, do. The extra weight has inertia, which makes it more stable. Whichever type you decide to buy, make sure it has a strong waterproof case. Keep it clean and stowed away from anything hot and protected from salt and being thrown around. Sextant gets its name from the arc at the bottom, which is 1/6 of a circle. Getting to know your sextant, do you have a sextant? If so, get it out of the box and have a good look at it. But before you do, make sure you only handle it by the frame and the handle at the back. All sextants are right-handed, so carefully remove it from the box with your left hand on the frame, and then transfer it to your right hand, holding the handle at the back. If you have got a lanyard, then put that around your neck. Just a small impact can ruin your sextant forever. First of all, let's have a look at the two mirrors. The lower one on the left-hand side is fixed in one place and is called the horizon mirror. It has a clear side and a mirrored side. The mirror at the top of the sextant is called the index mirror, which is just one flat mirror. This moves around when the index arm is moved. The sextant measures the angle between what you see through the clear side of the horizon mirror, usually the horizon, and what is reflected by the index mirror, usually the sun or another celestial body. Secondly, have a look at the telescope. This is fixed in position to look directly at the horizon mirror. Ensure the telescope lenses are clean and free from dust, etc. Next, check out the index arm. This moves backwards and forwards along the graduated arc. You squeeze together the locking device at the very bottom to move it. When you move the index arm at the bottom, it also rotates the index mirror at the top of the sextant. This enables you to line up the celestial body in the horizon mirror. You make big movements by pinching together the locking device, and then you make smaller movements by turning the micrometer drum screw on the side of the locking device around. The number lined up with the white stripe on the index arm is where you read the degrees from the arc. So in the photo below, we are looking at 61. Now look at the micrometer drum. The number lined up to the longer line next to the micrometer drum screw is the minutes of a degree. The slightly longer top line in the photo below, indicated by the red arrow, is a bit hard to see that it is longer in the pic. Your sextant should have one longer line. So in the photo below, the longer line is part way between the 1 and the 2. This means that our minutes are 0.1 plus some decimals of a minute. To find out how many decimals of a minute, we need to now look at the 5 shorter lines located below the longer one we used for the minutes. These are called the vernier scale. These are graduations for the decimals of a minute. Each shorter line equals 2 decimals of a minute. The decimals are measured on the graduation that lines up closest to the vernier and the drum. 8. Okay, I found this bit a little hard to grasp, but look close at the photo. There are 5 shorter lines below the one longer line. They each mean 2, 4, 6, 8, and 10 decimals of a minute. Which one do you think lines up best with any line next to it to form a straight line? You ignore the longer line you used for the minutes. I think it is the second shorter line down from the top. So that line means 0.4, so the reading from our sextant is 60.1.4. Hopefully that makes sense, but if not, please comment below and I will try to do another explanation of this. Another book I've read suggests that the decimals of a minute are probably at a level of precision that we are possibly unlikely to be able to obtain on a small boat. They suggest that you might just like to make a note of the degrees and seconds on the micrometer and not worry about the decimals on vernier scale. Sextant errors. The mirrors have to be exactly straight to provide the correct reading. There is an adjustment screw on the back of each mirror that you can use to check for any errors and make the relevant adjustments. You can see the silver screws on my sextant here. The two errors are called index error and side error. If you can't completely eliminate the index and side errors, then we can account for that when we do our calculations. We will talk about that in a future video. To check for index error, we can use the sea horizon, the sun, or an horizontal line like a chimney or a tall building in the distance. The sextant has an index error if the index mirror and horizon mirror are not parallel when the index arm and the micrometer drum with minute scale are set exactly at 0. If the error is more than 0.3 dos, we have to reduce it. We look at the horizon with the telescope. Direct horizon and the reflected horizon should be a straight line. Index error, no index error. We move the micrometer drum until we see a straight line. The reading on the micrometer is the index error. Make a note of this, as you will need to know that number when you start working out your sextant corrections. It is called index correction, IC. The measurement is either on the arc, or above 0, or off the arc, less than 0. Filters beside each mirror. You also have various different colored filters which can flip up and down. These are used to filter out the brightness of the sun so you don't end up blinding yourself. It is safest to put down all the filters initially and then reduce them by removing one at a time if necessary. Practice moving the filters around before you go lining up with the sun. Be very careful not to allow the sun to shine directly into your eyes. How to take a sight of the sun. Carefully remove your sextant from the box. Put the lanyard around your neck and hold it by the handle in your right hand. Check for any index error and side error. You need to check for these errors each time you use your sextant. Refer to the video above on how to do this. Make a note of the index error figure. Put all the filters down to protect your eyes from the sun. Set the sextant to 0 by adjusting the index arm and micrometer screw. This means that you are effectively looking through the sextant as though it were a telescope. Aim the eyepiece up at the sun so you are looking directly at it. Make sure you've got those filters all down. Now squeeze together the two knobs on the locking device, and while you keep the reflection of the sun in the mirror, slowly move the sextant down as you slide the index arm along the graduated arc until you get to the horizon. Once you see the horizon in the left-hand side of the horizon mirror, then you can make some adjustments with the micrometer screw. You preferably want to have the bottom arc of the sun sitting just on top of the horizon. Swing the sextant from side to side to ensure that the sun is sitting exactly on top of the horizon. Once you are happy with your sight, look at your watch, making a note of the seconds first, then minute and hour after that. You need the exact time of your reading for what you are going to need next for working it all out. Note that in rough conditions, it can be difficult to measure the actual horizon, and not just the top of a higher wave nearby. For this reason, it is better to be positioned higher in the boat if possible. At least 4 above sea level is preferable. Of course, this can be difficult to do on a small boat. Try to take the sights from the same position on your boat each time. You need to make an adjustment calculation for your height of eye, called dip, at the time of the reading, so make an estimate factoring in if you are heeling over and you are sitting on the high side, etc. You might like to record up to 5 sights one after the other to double check your workings. Time and altitude should appear to progress steadily as you take your sights, and any anomalies can be identified. This is good practice and your good sights can be averaged. Here is an example. UTC, Sunday 22 August 2003, 20 hour 54 minutes, 35 seconds 41 degrees 42. If you average the readings out, then you should get something close to your middle reading, and if not, then you might want to check again as you may have made a mistake. The reading that you take with your sextant is called the sextant altitude, and this is abbreviated as AEs. The HS figure is then corrected in a number of ways to obtain the true value of the observed object. This figure is called HO. We will learn how to apply those corrections in this video. Tune in next time when we learn about Greenwich Mean Time and Universal Time, and why we need this for our calculations. In a later video, we will then look at how to combine the reading we get from the sextant and the time that we took that reading to work out where we are. To keep up on my latest videos, please subscribe and hit the bell. See you on the next episode.